Good morning, I'm Vinay Dayal from 7G in DPS-GBN, and this is my submission for the Raman Awards competition. Okay, so my project is on the Archimedes principle, and I think it's better to give a bit of background info on Archimedes himself. He was a brilliant inventor and a scientist. He lived in Sicily and played a huge role in the making of modern technology and in science too. He made many devices and principles which were very important, but this video is only about one in particular, the Archimedes principle. So the Archimedes principle is basically a principle which states that if a body is immersed in a fluid such as water, an equal and opposite force will be felt. Well, equal and opposite to the weight of the water displaced by the object immersed in the fluid. This also depends on the density and shape of an object. This force is known as buoyant force. I'm talking about the opposite and equal force. This is a bit like one of Newton's laws, which clearly states that each action has an equal and opposite reaction. So, I'll be using a tip to explain this principle. When you press a body down, force is applied and equal force is returned. But there is one condition. The equal force depends on the weight of the water displaced and the object. If it's equal, it's all good and it will float. It doesn't need to be exactly the same. It can also be a little bit more, the weight of the water. Then it can float comfortably. If not, then it'll sink. It also helps if air is in the object too, like in our body and in Project 2. Project 2 is basically a project that anyone can do anywhere, and I'm using it to prove the Archimedes principle. I call it the mug floater. So, all you need to make this project is a bucket, a lot of water in the bucket, and an empty mug. Instructions for the experiment. All you need to do is push the mug upside down. Well, first make it upside down, turn it upside down, then push it down in the bucket with some force. You will feel some buoyant force. Increase the force applied and it'll go down pretty easily. Why doesn't it give more buoyant force? Why isn't it harder to push it down? This is actually because the mug has displaced very less water due to its shape. Also, the mug wasn't empty, it had air in it. That air has made it harder to push down. To prove this, do it again. After the mug reaches the bottom of the bucket, slightly tilt the mug. You will notice that the air escapes in the form of tiny bubbles. Well, not so tiny. Okay, now for inverted mug floater. If you let the mug go, it'll emerge on the surface of the water. Now, let's do the second part. Last time we held the mug in an inverted position. So now we will hold it in the non-inverted position. So, after doing the same experiment with the same equipment, we can observe that it's a bit harder to push the mug downward when it's in this position. But why? This is because of the fact that the flat side of the mug, the bottom of the mug, covers more space. Because of this, the buoyant forces increase. Now, we will compare it to a large body in a fluid. Now, we can compare it, I've compared it to Project 2, Part 1 of it, to a human in a pool. What if a human presses the middle of his or her body down? Then, the person will get a similar result. The buoyancy will increase, and it'll be much easier to float. Therefore, we can conclude that anyone can use this tip based on the experiment. Thank you.